I wanted to take the time now to introduce the key concepts that we'll cover in class so you can have an appreciation for our goals for the entire semester and what I hope you will be able to take away from the course and add to your knowledge base about materials science. So, as the title of the class implies, we're going to study material issues in mechanical design. That means that most of our study of material science will be limited to the mechanical aspects of materials and using them in basically structural situations. Typically when mechanical engineers design with materials, this is one of their primary design goals. What that means is that we aren't going to talk about the optical properties, the electrical properties, and some of these other very important aspects of material science are not going to be the focus of this class. They may come up a little bit in case studies or projects, but they won't be our focus. In a way, this class is meant to follow an introduction to materials science class that you may have taken as an undergraduate student, where you probably learned the basics about the structure-function relationships of materials and the different classes of materials: metals, polymers or plastics, ceramics, composite materials, and semiconductors. Our class is going to focus on the first four of those materials: metals, ceramics, polymers, and composites, and not much on semiconductors because those are mostly used in electrical and other types of non-mechanical situations. In particular, we're going to go through 10 units in the course of the semester where we'll focus on different aspects of material use in mechanical design. We'll start with a review of material science and then move on to talk about fracture mechanics and how cracks propagate in materials and brittle failure. In that context, we'll bring up other failure modes as well. It's very useful if you're trying to design and use materials in mechanical design to go back and look at how they fail in mechanical design. So we will also introduce case studies through the course of the semester, and particularly at the end of the semester, to look at famous failures from history, as well as failures that may have popped up during the course of your work or in my laboratory or other things that may happen during the course of the semester. After we talk about fracture mechanics, we'll move on to talk about stress concentrations and how to design around stress concentrations. And then we'll get into multi-axial failure criteria, where we look at more complicated loading scenarios than simple tension or compression, or bending for that matter. After multi-axial failure, we'll talk briefly about high strain rates and some of the unique aspects of material behavior that occur when loading rates are very high or fast. We'll then spend a considerable amount of time on the subject of fatigue and basically the cyclic use of materials and how they fail differently when they're loaded over and over and over again rather than under a single loading scenario. And then we'll finish up with looking at the effects basically of the environment: high temperature situations and creep, hostile environments, particularly corrosive environments, also the effects of radiation and other things like that, and a little bit about wear and fretting, which is kind of a unique mechanical situation. At the end of the semester, you'll kind of bring all these ideas together in studying case studies as well as doing your own project with a group of students, where you'll either look at a failure analysis scenario or perhaps a redesign of a situation to prevent failure in the future.